In this lecture, we will be seeing another example of Turing machine where we will see how to design a Turing machine for a given language. So our task is design a Turing machine which recognizes the language L equal to 0 power n 1 power n. That means we have to design a Turing machine which accepts this kind of language where the number of zeros should be exactly equal to the number of ones that follows. That means if you have n number of zeros, then you should exactly have n number of ones that follows those zeros. And if you remember, we have talked about this example even in our previous lectures when we discussed about finite state machines, and we saw that we could not design this using finite state machines. Why? Because we need to keep a count of how many zeros are there in order to repeat the exact same number of ones so that we can achieve this language. But we saw that finite state machines, due to their limited memory and due to their limited capability, it was not possible to design this language using a finite state machine, and hence we said that this is not a regular language. This particular language is not a regular language. So we shall see in this example, using a Turing machine, how can we design this language. So first of all, I will explain to you the algorithm of how this can be done. We will design an algorithm which will be able to accomplish this task of accepting this kind of strings, and then from this algorithm we will see how we can design the equivalent Turing machine for it. Alright, so here we have the tape sequence which is there in our Turing machine, and then the algorithm, it says that the first step says change 0 to x. We are going to replace the first 0 in our tape to x, and then we will move right until we find the first one, and if you cannot find the first one, you have to reject. That means the string will not be accepted. And if you are able to find a 1, you have to change that 1 to y, and after you do that, you have to move left until you find the leftmost 0 in the tape. And this process will be repeated until no more zeros are there, and you have to make sure no more ones remain as well. Alright, so don't get confused by seeing this algorithm. I will explain it to you using this tape. So let's say that we have our tape over here, and then there is an input in this tape 0 0 0 0 1 1 1 1. So we see that we have 4 number of zeros followed by 4 number of ones. So the number of zeros and ones are equal, and hence this string should be accepted by the Turing machine that we are going to design. So let's see how this algorithm works. So it says change the first 0 to x. So first of all, I have my tape head over here, and then I see that there is a 0 over here. This is my first 0. So this 0, I replace it with an x. This is what step 1 says. Then you have to move right to the first one. So I have to move my tape head right until I find the first one. So I have to move step by step to the right. One step to the right, one step to the right, one step to the right, and when I take the next step to the right, here I find my first one. So when we find the first one, what you have to do? You have to change that 1 to y. So I will change this 1 to y. Okay, and then what we have to do, you have to move left to the leftmost 0. So I am over here right now, and I will keep moving left until I find the leftmost 0. So let me move left step by step, one step to the left, one step to the left, one step to the left, and here I find that this is the leftmost 0, because here I don't have 0 anymore, it is an x. So here I find the leftmost 0, and what does it say? It says repeat the above steps until no more zeros are to be found. So I have to do the steps that I just did. So when I find the 0, I just replace it with x, and then again I have to move right to the first one. So I move right like this, and here I see that this is not a 1 anymore, this is a y. So which is the first one now? It is this one. So I will replace this with y. Now I have to again move left, searching for the leftmost 0. So as I move left, this is the leftmost 0. I replace it with x, and then I move to the right to the first one. Now which is the first one? This is the first one. Now I replace it with Y, and then I move left again, searching for the leftmost 0, which is this one, and I replace it with X, and then I move to the right, searching for the first one, which is this one, and I replace it with Y. Now if I look, there are no more zeros present, and also all the ones are consumed. So our tapes looks like X, 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 Y, 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 and the next symbol is a blank symbol. So this string will be accepted. When you are doing this, like suppose you find a 0, and when you go searching for the 1, if you don't find a 1, then you will reject. That means the number of zeros is not equal to the number of ones. So in that way you can find if the number of zeros and number of ones are the same. So this is the algorithm that we need to follow. Now let us see how we can design the Turing machine for this using the transition diagram of the Turing machine. So here I have the Turing machine, which is going to perform exactly the same task that was written in our algorithm that we just saw before. Now let's see. Here we have the starting state, which is A, and then we have states B, C, and D, and we have the accept state. Now if you see, there is no reject state that is mentioned over here, and it doesn't mean that there is no reject state. It means that whenever there is a missing edge for any transition, that will implicitly go to the reject state. So it is just that we have not specified it separately, but there is a reject state. And where is a reject state? Any edge that has a missing transition, that will go to the reject state. Alright, we already said that Turing machines, they are deterministic. The ones we are designing, they are deterministic. So in determinism, what is it? You need to have a transition for every input for every state. And in Turing machine, you also have to consider the blank symbol. So if you see that in state A, it has transition for 0, it has transition for Y, and it has transition for the blank. But we see that it is not having transition for 1, the symbol 1. So if you get a 1 in state A, that means it goes to the reject state. And that is true because in the kind of language that we are going to design, we want zeros followed by ones, not ones before zeros. Okay, so that was just an information. Now let's see how this works. So we are in the starting state, and in the starting state we get the first 0. So when you get the first 0, what you do, you replace it with X and you move right. So here is my tape head. I replace this 0 with X and I move to the right. And now I am in state B, and in state B what happens is that, what is the next step? As I told you, from here you have to go to the right, searching for the first one. So you have to reach till here, and state B will help you do that. So in state B what happens, whether you encounter a 0 or Y, whatever it is, we are not going to replace them with anything different, but we are going to write the same thing. So that basically means that you are not replacing anything. Alright, and then you just keep moving right. So if you are getting zeros, replace it with 0 itself and move right. So 0, 0, 0, and then here I encounter my first one. So when I encounter my first one, what happens? I have to replace that one with a Y, and then I have to move left. So I have to replace this with Y, and then I have to move left. So my tape head was here, so it will come over here now. And then in state C, this state C will help you to go back until you find the leftmost 0. So in the algorithm, I already showed you, after you reach here, you have to move left until you find the leftmost 0. So this state C will take you left without replacing anything different. That means if you see a 0, you write a 0. If you see a Y, you write a Y. So basically it means you are not replacing anything, and you just keep moving left. So I keep moving left like this, and till when do I move left? Till I encounter an X. So I move from here to here, and I come here, and when I reach here, I encounter an X. This is not 0 anymore, this is an X. Now when you encounter an X, you understand that following that you will have the leftmost 0. So what happens when you reach this X, you move one step to the right. So after reaching this, I move here, and my tape head is over here. right now. And then what happens? You come to state A, and then in state A, if you see 0 again, this whole process will continue. And yes, I am seeing a 0, so the whole process has to continue. So this will be replaced with X, and then we move right, and this will be replaced with Y, and then again we move left, replacing this with X, and then we move right, replacing this one with Y, and then we move left, replacing this with X, and then we move right, replacing this with Y. Okay, now let us say we reach this condition. After coming to state C, we reach this X over here, and then we move one step to the right, so my tape head is over here now. And what happens? I encounter a Y. So I'm encountering a Y here, and what happens? I am not replacing that Y, I am just putting Y itself, and then I move right, and then I move right. And then what happens? State D will help you to move right again and again. So this state D will help you move right by replacing Y with itself. That means basically not replacing anything. So we move from here to here, and from here to here, and then we come over here where we encountered the blank symbol. And when we encounter the blank symbol, what does it say? Move one step to the left and accept it. So my tape head will come over here, and then my string will be accepted. So this string 00001111 will be accepted. So that is how this Turing machine works. So we saw how it is working. How it works is that when you see a 0, you search for a 1 at the same time, and then again you search for 0, and if you find a 0, you have to search for a 1 again. So basically what it is doing, it is searching a 0, and then it is searching for a corresponding 1. And again it is searching for a 0, searching for a corresponding 1 for that 0. And at any case, if it does not find a corresponding 1 for a 0, then what happens? It will not have a transition. So all these transitions are for the accepting conditions. And then if something happens like what I told you right now, there is no transition. So it by default goes to the reject state, and that string will not be accepted. Now there is one transition that we did not talk about, which is this one. So here in the starting state, if we get an empty symbol, that means a blank symbol, we move left and we accept. Why we do this is because we also want to accept the empty string. If we are having an empty string, that also we want it to be accepted. So that is why we are having this transition. So let's say that we are having an empty string. In an empty string, what is there? It is empty. So in the tape, you will have only the blank symbol. So suppose this is your tape and you have only the blank symbol. So if you see the blank symbol, replace the blank symbol with blank itself and move to the left and accept. Now one question that may come to your mind is, how can you move left when you are already in the leftmost position of your tape? And this thing I already taught you in the first lecture of Turing machine. In the rules we have learned that if you are in the leftmost cell and if you try to move left, then what you do? Don't move left, just stay where you are. So you just stay where you are and go to the accept state. In that way we can also accept the empty string.